Hello and good day, everyone. Today we will have another example on using the graphical method for velocity analysis for mechanism. Okay, so for today's video, the problem is in a crank and slotted lever mechanism. Crank rotates at 300 rpm in a counterclockwise direction. So find the angular velocity of the connecting rod, which is the connecting rod is this point A and B, and the velocity of the slider, which is here. Okay, so this is now the your slider. So we need to find the angular velocity of this connecting rod. If this is the crank OA, and the connecting rod is AB, and the slider is this block here. So we need to find the angular velocity of this AB and the velocity of this slider. So as mentioned by the problem, velocity of the slider, so it follows no one good. Based on the figure, the velocity of this block is always linear lang. So walay angular velocity. Again, the first thing to do is to select or draw the space diagram of the mechanism. So again, we need to set a scale. Sorry, the problem is missing some values. So it's 45, it is 150 mm, and this is 60 mm. Okay, so we need to use a scale in order for us to draw the space diagram for this mechanism. So let's say we will use 20. So no, use 1 cm equal to 20 mm. So it follows that length OA is equal to 60 divide 20 mm. So it is equal to 3 cm. And length AB is equal to 150 mm divided by 20 mm, which is equal to 7.5 cm. Okay, so with that, we know that it is 45 degrees and it is a crank slider. So now we can draw a space diagram for this. So let's start with identifying the fixed point, which is the fixed point is this point O. Okay, point O, our fixed point. Okay, the next thing to do is we know that this length OA is the length is 3 centimeter in the space diagram, and it is located 45 degrees from the x-axis. Okay, so we just need to use, so we will use, okay, so to make it simpler, no, you can draw a line here, a perpendicular horizontal line for coin. Just a temporary line lang, class. Okay, a temporary line. Then use this protractor to measure 45 degrees. Okay, 45 degrees. So 45 is around here. Okay, that. Then measure 3 centimeter. Okay, the location of OA is, or the length of OADI is 30 centimeter man. Or 3 centimeter rather. So 3 centimeter. So kani going that. Substitute lang nato para mas clear. So that's length OA. Now, using a compass, we know that the length of A to B is fixed, which is 7.5. So measure a 7.5 length or radius using your compass. 7.5 around here. Okay. So using this length, a radius, create an arc. Okay, create an arc here. Okay, so since we draw this horizontal line here, kay kabalo man tadaan nga the point B is also located at this horizontal line here. So therefore, we just need to intersect the arc created by this circle, which is having a radius of 7.5 and its length. Kaya since dili man gihatag ang ano OB nga length. So this is now the point B. So you just need to intersect these. You just need to connect these 2 points. Okay, so now we have the space diagram. This is point O, this is point A, and point B. Okay, so you can create another one. If you want, you can connect this. This is the first consider as one. Okay, so the next thing to do is to use whatever available, no, so that we can find given data na lang, makakuha tag isa ka data for our vector so that we can draw our vector diagram for the velocity. So we have the 300 RPM nga the speed daw ni siya sa crank OA. Now as mentioned in the beginning that the crank rotates. The crank is here. Kani atong crank OA. The crank rotates 300 RPM in a counterclockwise direction. So find the angular velocity of the connecting rod and the velocity of the slider. So using the formula, which is the angular velocity of crank OA is just equal to 2 pi n over 60, which is equal to so we just convert sa 2 pi tapos 300 divide 60. So we have a formula of so it is equal to 31.42 rad per second. So kindly check na lang class no for the value. Okay, since I don't have the calculator, I'm just using an ordinary calculator for this. So the relationship between the linear and angular velocity is using this one. Link OA multiplied by angular velocity of OA, which is OA is equal to the length of it is 60. So 60 over 1000 times 31.42 rad per second. So therefore you have 1.89 meter per second. Okay, so after that you can now proceed in creating your vector diagram. So but before we can draw that, we need to set another scale na pod, no, so that we can draw our vector diagram. So let's say for example let's stick with our previous example, no, that the scale is 1 centimeter equal to 0.2 meter per second. I hope that it will come. So we just need to divide this velocity by 0.2. So you have 9.4. So I think it's quite long. So maybe let's change. I think it's, let's say 0.3. So 1.89 divide 0.3. Okay, so maybe it's enough. So let's say 0.3. So therefore, using 1.89, VOA is just equal to 6.3 cm. Okay, so let's use this. Then now, locate the fixed point. We know that from using this figure, no, the fixed point is only one, which is this point O. No, because this is an imaginary line lang. So we know that this is just the axis of, or this is the axis in which the crank will uh, move. Okay, so but actually wala na siya link there. Okay, so just select point O as your fixed point. Point O. Okay, so point O. Now, the velocity OA is 6.3. We know that it will act always perpendicular to the its link, which is the link is kani. So we need to create a perpendicular line for this one. Then try to use your calculator, no calculator, triangle. Sorry. So use this class. Then ano, so medyo dili siya accurate yun ang graphical method. But it is very easy to using this locate imaginary temporary line, then measure 6.3. I hope it is it can be seen also in the video. Okay, 6.3 is around here. Okay, so just draw. Okay, let's let's change, let's change the point because the rotation is counterclockwise. So counterclockwise ang rotation. So therefore, if this is your point O, the next point of A is kani. Sorry for that. Because the rotation is going counterclockwise. So this is point O, the fixed point, padulong dito ang atong crank. Okay? So kung padulong dito ang crank, ang point A is dito po siya malocate. So be careful with the rotation pod or the direction of the rotation. Okay? So next is we need to determine the perpendicular or the linear speed of this crank AB. So again, it is perpendicular to this line. So just use your ruler. Sorry. Use your ruler and triangle. Then connect this. Okay, connect. Yeah, this imaginary line. Okay. So after that, then you just need to because we know that the movement or the motion of this B is always in the diagonal nga axis lang. So therefore, we just need to connect this. Diagonal lang. So naroon na siya diha. Okay? So intersection niya, this is now the point B. The point B. So connect lang ninyo guys. Connect lang. Then connect. So this is now your point B and this is your point A. So rotate, this is the speed VOA or just equal to VAO, the velocity of A relative to point O, and this is the speed of A relative to speed of B relative to A, and this is the speed of B relative to O. Okay, so we're almost done. We just need to measure. So its length is mga around 5.7. So velocity B relative to O is just equal to 5.7. cm. Then the velocity of BA is equal to 4.7 rin. Ano? 4.7 cm. But our scaling is 0.3 meter per second, so you just need to multiply this by 0.3 and multiply this by 0.3 so that we can have a value for so 5.7 multiply by 0.3, so 21, 15, 17, so 1.7 1.71 meter per second. Then 4.7 times 0.3, 21, 12, 14, so 1.41 meter per second. So the problem asked that we need to find the angular velocity of the connecting rod, which is the connecting rod is the AB. So we just need to convert this angular or this linear velocity using itong relationship na formula. So link AB multiply by angular velocity BA. So 1.41 meter per second equals to AB is 150 divided by 1000 times angular velocity of BA. So therefore, you have a value of the angular velocity of BA is just equal to 1.41 divide 0.15 rad per second. So I leave this to you guys to solve the value. Then for the velocity of the slider, it is equal to 1.71 meter per second because it is already a linear speed. Okay, so this 2 here is the answer. So I hope that you understand the procedure of or the graphical procedure of velocity analysis for our mechanism in machine design. So if you have questions, you can ask me in my class. So that's all. Thank you and goodbye.